Okay, just as a quick review, remember what we're using is we're using the reciprocal identities, the quotient identities, and then the new ones that are going to be the biggest thing are the reciprocals. Pythagoreans. So cos or sine squared plus cosine squared equals 1. 1 plus cotangent squared equals cosecant squared. Tangent squared plus 1 equals secant squared. So these are going to be the ones that you need to make sure that you're memorizing. At least memorize this one and know how to get to these. All right. All right, so what we're doing is we're working on factoring. Biggest thing is just to realize that whenever we're doing these functions, we can treat them just like variables whenever we're doing factoring. So they work like anything else. So whenever I have something that looks like this, notice that we're just working with terms. This is one term, this is another term. What do those two terms both have in common? Sine x. So I can pull that out just like I would pull out a normal x. Okay, just since, it's been like a week since we've had it. This is a Pythagorean identity. I can subtract the cosine squared from both sides. If I multiply both sides by -1, I can get that. So cosine squared x minus 1 equals negative sine squared x. So then I can substitute that in for this. Because remember, when we're simplifying, we're trying to get to a single trig function. So then I can multiply that back out and get negative sine cubed x. So really, when we're doing the algebra with these functions, we're just treating them like variables. And then we're doing all of our algebra with them just like they were just normal variables. So I could really do this entire problem except for the trig identity. Besides that, I could do this entire problem like it looked like this. Y x squared minus y. Okay, now, most of your homework is going to force you to factor. What it's going to tell you to do is factor and then simplify. Because what they want you to do is they want you to practice on factoring. Again, whenever we factor with these, we factor just like they were normal variables. So, factoring this is just like factoring this. So if I was factoring that, I'd just find two numbers that multiplied to 6 and added to 5. So that'd be 2 and 3. So that means with this over here, it's the same exact thing. Two numbers that multiply to 6, add to 5 are 2 and 3. So the factored form of this would help if I actually wrote it correctly. is that. And then we look after we factor, can I simplify anything? With that one, I can't. So I'm done. A lot of your factoring ones today, you won't be able to simplify anything. Again, the goal of your problems today, it's not necessarily simplifying, it's more of practicing factoring. Just factoring with the trig functions in there. All right, a couple more, and then we're done, I promise. Okay, so if I take that and factor that, what would that be? Yeah, that would not fit the Pythagorean because it has to be a plus one. So that one would be difference of squares. So again, it's just like factoring this. X squared minus 1. And then I wanted to do one where we could actually simplify something. So if I factored this one, I would get sine x plus 1, sine x minus 1. Now, yes, on this one, I could use Pythagorean, but again, your instructions will tell you to factor first. They do not want you simplifying. Yeah. They want you to practice factoring, so they're going to tell you to factor first. Then, after I factor, then you can simplify. Now, part of the reason they're telling you to do that is because, yes, I could change that with the Pythagorean, but that actually messes you up. Because part of the reason is you want to get rid of fraction and get to a single trig function. Well, if I change this into cosine, it would change me into negative cosine squared x. That's actually counterproductive. That gets you to two trig functions, and it does not get rid of your fraction. So part of this is also showing you some methods to help you solve your problems. So we don't want to do that anyway. Okay, any questions? All right, there you go.